Amines are derivatives of ammonia. Ammonia is NH3. That's ammonia. Okay. Most important type of organic base found in nature. We substitute ammonia with different groups. In other words, here's NH3. We substitute 1R group for a hydrogen. Or we can substitute 2R groups. Or we can substitute 3R groups. Okay. And they're different types of amines. The R can be either aliphatic or aromatic. Okay. Aliphatic just means it's a carbon chain. Aromatic means it's a benzene ring. That can be substituted, a phenyl group. Okay, thanks. They're gonna go get some pizza. Get me a good one.
Onions and all.
Yep, perfect. All right, so amines have a trigonal pyramidal structure. Everybody remembers the Vesper rules from chemistry?
No, they're inside.
Valence shell electron pair repulsion. So if you got 2 free electrons up here, then you got your 3 bonds. One comes out of the board, one goes in, and one stays in the same plane. So it's a tetrahedral electron geometry, but there's nothing bonded to those electrons. So this is a trigonal pyramidal structure. Okay. And where are we at? So this is ammonia because it has the 3 hydrogens. And when you start substituting it, either 1 group, 2 groups, or 3 groups are, it becomes an amine. It doesn't have to be all 3. It could be any one. You can have 1R group, have 2R groups, or 3R groups. And they're all amines. There's different types of amines. Okay. So we're going to classify amines. They're classified by the number of carbon atoms that are directly bonded to the nitrogen atom. So which ones go directly to the nitrogen atom classifies your amine. Okay. A primary amine has 1 R group attached. Okay, so R and H2. So one of the hydrogens has been replaced with an R group. That's your primary amine. A secondary amine has 2 R groups replaced. Okay? So 2 of the hydrogens are gone. And now you've got the 2 R groups. Okay. A tertiary amine, I bet you can guess what that is, right? Tertiary amine has 3 R groups attached to it. All the hydrogens have been now replaced. So primary, secondary, and tertiary amines. If there's no R group, it's ammonia. If there's 1, it's a primary amine. If there's 2, there's a second. There's 3, it's a tertiary amine. Okay, and that's what they look like. So this is ammonia, primary amine, secondary amine, and tertiary amine. The R groups are directly attached to the nitrogen. Okay. And we'll learn how to do the different nomenclatures, how to name these things also as we go along. So this would be methylamine, methanamine, N-methylmethanamine, and N-dimethylmethanamine. And we'll learn how that's the IUPAC nomenclature for these. So we'll learn all that good stuff too as we go along here. Oops, wrong computer. All right, so classify each defined compounds as primary, secondary, tertiary, and compare each with that of ammonia. All right, what is that? Primary, secondary, tertiary?
Primary.
Primary, exactly. It's got 1 hydrogen replaced by an R group, by the methyl group. So that's primary. What's this one?
Secondary.
Secondary, perfect. And you can probably get this one too. That
Tertiary.
yeah, you got it. Perfect. It's tertiary. So, it's pretty straightforward. Primary, secondary, tertiary amines. Okay. This one here is a, which one?
Tertiary.
Tertiary amine. Perfect. You guys got this down pat. This one here is a
Primary.
primary amine. Only
Primary.
1 R group attached. Primary. Perfect. Because you got 2 hydrogens on it. And that one is a secondary amine. You got it. And this one again is a primary amine. Like I said, that's pretty straightforward. Don't worry, it'll get tougher. We won't leave it this easy for you. All right, and that is a tertiary amine, right? You got 3 R groups attached. No hydrogens directly attached to this nitrogen. That's the key. It's not directly attached to the nitrogen. Okay. And this one here is what? I'll let you guys get this one. I guess so.
Secondary.
So primary, secondary, or tertiary?
Secondary.
Secondary, you got it. All right. Dealing with amines, we deal with the nicotine patch. The nicotine patch. Smoking cigarettes, one of the difficult habits to break. If you have your own smokers, it's extremely difficult to break. I've had friends who have quit smoking several times. It's a very hard habit to break. Physicians now suspect that smoking is more than a habit. They're actually calling it an addiction. Okay, for insurance purposes now, with what's the drug I'm thinking of? Chantix. Okay, we're labeling it as an addiction now for insurance companies to pay for it, not just a habit. Okay, the addictive drug in tobacco is nicotine. Nicotine is a heterocyclic amine. Okay, it means it's in a circle with a nitrogen compound in between it. It's a highly toxic compound. Okay, it's been used as an insecticide. Okay, so not something you really want to put in your body. Small doses from cigarette smoking initially stimulate the autonomic nervous system. Your autonomic nervous system is your system that when you use it relax. When you sit down, you sit in the chair, watch TV, eat your dinner, whatever you're doing, that's when your autonomic nervous system kicks in. Remember from anatomy, your fight and flight versus your autonomic, your parasympathetic and sympathetic nervous systems. Okay, so it's your involuntary system that keys it up when with this nicotine stimulates that system. So you're more awake, more aware of your surroundings. That's why people smoke. Repeated small doses obtained by smokers eventually depresses the involuntary nervous system. So you need more to keep it going. You get that stimulation and you like that feeling. Okay, the more you smoke, the more it takes to get that stimulation, because the nicotine starts to suppress that same nervous system after you get used to it. So it takes more and more and more, and that's why you see chain smokers. Where I've got people that I deal with that they'll light another cigarette before the other one's even out. They just got to keep that nicotine goes coming to keep that autonomic nervous system stimulated. Okay, as a result, smokers need another cigarette. It's something they just want they want to keep going. So some people have been able to quit smoking through behavior modification programs like hypnosis or sheer willpower. Sheer willpower is extremely difficult to do. Going cold turkey with smoking is very difficult. Very hard addiction to break that way. Hypnosis can be very successful. Hypnosis is a phenomenal tool that we can use. We use it in dentistry a lot with a lot of our patients. It's phenomenal. It can actually help people overcome an addictive habit. Others quit after smoking has contributed to life-threatening illness, such as emphysema or heart attack. Once they've had something wrong with them, then they realize they better stop. And that's when they stop smoking. Okay. Yet there are people who cannot quit even after a diagnosis of lung cancer. When I was in the hospital I had an emergency appendectomy. When I was in the same room with a guy who was in there for a lung removal for lung cancer, and he was smoking, and this is when you can smoke cigarettes in the hospital. Because I'm that old, yes. Okay, so he was in there, and he was in there smoking because they wouldn't let him smoke during surgery. So he was smoking a cigarette before he went in. I'm going, you're losing a lung already. You're only gonna have one left, and he's still sitting there smoking. And it's a very, very bad addiction. One promise to help quit smoking is a nicotine patch that we use. Okay, patch is applied to the smoker's skin, and nicotine from the patch slowly diffuses through the skin and into the bloodstream. Okay? Because the body receives a constant small dose of nicotine, the smoker no longer craves a cigarette to produce that same effect. And that's how a nicotine patch works. The longer it goes to completely cure the addiction to nicotine, because you can take those patches and reduce the amount of nicotine, the concentration of it in the patches. Okay? So you decrease the dose of nicotine in the patches as the treatment continues, and you slowly wean yourself off the feeling for nicotine. So eventually, about 3 months, usually it takes to do it, the former smoker no longer needs the patches. Okay? People criticize this because nicotine is a toxic chemical, and you're still putting a toxic chemical in the body, but you're using it to decrease a worser habit, a worser addiction to it. Okay? However, benefits seem to outweigh the negative aspects. So a smoker not only has nicotine, but there's dozens of other substances that have been shown to cause cancer in a cigarette also. So not just the nicotine. When someone says has to quit smoking, the body no longer suffers the risk associated with the substances in cigarette smoke. Okay, Chantix, the new drug on the market. What was new about 8 years ago, 9 years ago now? There are some problems with it. Okay, but Chantix can cause drowsiness, which may impair your thinking or reactions. Okay, it's a fantastic drug for what it does, though. You may also have mood or behavioral changes when you quit smoking. We've all experienced that if you know anybody that's tried to quit. Okay, until you know how Chantix's smoking cessation process is going to affect you, be careful if you drive or do anything that requires you to be cautious or alert, because Chantix can be a sedative. You gotta be very careful with it. Okay. Stop using medication and call your doctor once if you have any mood or behavior changes, or if you feel agitated, hostile, depressed, or thoughts about suicide. Now, suicide has been a problem, especially when we deal with Chantix with the Marine Corps. We have a program in the Marine Corps Hospital, 29 Ponds, that I was involved with when I was active duty. We put these Marines on Chantix. Chantix doesn't cause depression and suicide. What's happening is nicotine suppresses your dreams, your REM sleep patterns. A lot of Marines have been through a lot of nasty stuff as they're deployed. PTSD, a lot of other problems. When they smoke, smoking stops them from dreaming. They don't get those feelings of dreaming up the bad things that have happened. Chantix brings that back because now you're decreasing nicotine. So the dreams are coming back. So a lot of these Marines have these dreams come back that exacerbate their PTSD, and it has led to suicide. So it's not the Chantix actually causing the suicide. It's not one of the side effects of the medication. What it is you're not having nicotine in your body anymore, so the dreams are not being suppressed, so the dreams are coming out, causing depression. So it's something you have to really watch, especially on the Marine Corps base when we use Chantix. It's common in the regular population also, but more so with the Marines because of what they do for a living. So it's something you definitely have to be aware of. So, and those passages are through amines. We'll get to what those are in a minute. But physical properties of amines. Amines form hydrogen bonds, just like OH forms a hydrogen bond, NH forms a hydrogen bond. It's not as strong as alcohols. Okay, alcohols, oxygen is more electronegative than nitrogen. So oxygen pulls those electrons closer, giving it a stronger negative charge, and the hydrogen a stronger positive charge. Nitrogen is still electronegative more than hydrogen, but it's not as much as oxygen. So it does pull electrons towards it, but not as much as oxygen. So you do have hydrogen bonds, but they're not as strong as the hydrogen bonds formed when you have oxygen, when you have alcohols. So nitrogen is less electronegative than oxygen, attracts electrons a little less. Tertiary amines cannot have hydrogen bonding. There's no hydrogen. Remember, every one of the hydrogens has been replaced. Remember, you have nitrogen with 3 hydrogens. Every one of those hydrogens has been replaced. So now you cannot have hydrogen bonding. So you only have hydrogen bonding in ammonia, primary amines, and secondary amines. Okay. Tertiary amines cannot have hydrogen bonding. Okay. And this is the same thing we have like with water or alcohols. We have the delta plus here for the hydrogens, and then the delta minus for the nitrogen, and you get a bond of attraction. You get a hydrogen bond attract. Okay. Just like with water, you have the hydrogen bonding. Okay, so nitrogen amines are soluble in water. Low molecular amines can be soluble in water because they'll bind with water because of the hydrogen bonding. So draw a figure showing hydrogen bond that occurs between water and a secondary amine. Okay, so here's water. Remember, delta minus, delta plus, delta plus. This is delta minus. This is delta minus. This is delta plus. So positive and negative charges attract. Positive and negative charges attract. Okay. That's what causes hydrogen bonding. Again, it's not as strong as water. It's not as strong as alcohols because the OH group, but it still is hydrogen bonding, and it still forms a bond between those. Draw one between 2 primary amines. It's the same thing. Those are both primary amines. And you get delta minus because it attracts electrons, and all the hydrogens are delta plus. Okay, so delta plus, delta plus, delta minus. And again, you get this hydrogen bond here because opposite charges attract. Okay, boiling points. We're talking about different boiling points. Amines have boiling points between alkanes and alcohols. Alkanes are your carbon hydrogen single bonds. Okay, alcohols have hydrogen bonding, so they'll have a high boiling point. Amines can be just between those two because they have hydrogen bonding, but not as strong as the alcohols. Okay. Structure of amines. Okay, each one's individual here. All right, so this is a alkane. This is a primary amine. This is an alcohol. Okay, and we're going to compare it. Oh, you need to go out? Oh, you're not? Okay, we'll close that. Okay. All right, so we'll compare those here. The name of that is, we should all have that, that's propane. The name of the amine is going to be ethylamine. It's an ethyl group you can see attached to amine. We'll get to name those in a second. And then that is ethanol. Okay, similar molecular weights. Okay, so molecular weight is going to be 44, 45, 46. So similar molecular weights. Boiling points. Which one of those three, just from what we already talked about, is going to have the lowest boiling point?
Alkane.
Perfect. Propane. Which have the highest boiling point?
Ethanol.
Ethanol. Perfect. Exactly. Propane has no hydrogen bonding at all. The ammonia group has some hydrogen, has hydrogen bonding, but not as strong as the alcohol. So the alcohol is going to have a highest boiling point, your lowest boiling point, and it's going to be right in between those. Okay. So tertiary amines boil lower than primary or secondary. Remember, tertiary amines have no hydrogen bonding because there's no hydrogen to do it with. They've all been substituted. Okay, so let's put our structures up here. This is a primary amine. This is a secondary amine. And this is a tertiary amine. Okay. So this would be propylamine, methylethylamine, and this would be trimethylamine. And we're going to name these in a little bit as we come down through there. Molecular weights are all similar. They're all very similar, actually. Boiling points. So which one's going to have the, let's start off with the highest boiling point? The primary, secondary, tertiary. What will have the highest boiling point? No guesses? It would be the primary amine. Because think about it. The tertiary amine has no hydrogen bonding to hold it together. The primary and secondary ones, the primary has two hydrogens. The secondary one has one hydrogen to bond. So the primary one's going to have double the amount of hydrogen bonding as the secondary one. Just simply by the fact it has two hydrogens instead of one hydrogen. So the primary is going to have the highest boiling point, 48.7. Then it goes down for the secondary and down for the tertiary. So your highest boiling point is going to be your primary amine. Again, you've got two hydrogens, double the hydrogen bonding. Okay. So we talk about boiling points of amines. We just got a chart here, ammonia, which shows your pain. These are methylamine. This group is all primary amines. This group is all, I'm sorry, where am I at? No, this is a tertiary amine right here. So this is primary, secondary, and tertiary going down the list. Primary, and these are all primary right here. But it shows the different boiling points of the different amines here. As the chains get longer and bigger, okay, the boiling point gets higher. More structure to hold it together. Okay. And we compared some of these already. Methanol, this is an alcohol, methylamine. You can see similar molecular weights. This is the alcohol, and this is the primary amine. Okay. Alcohol has a stronger or higher boiling point because it has stronger hydrogen bonds that hold together, make it harder to break it apart. Okay. Again, ethanol and ethylamine, same thing. The alcohol has a higher boiling point because of the hydrogen bonding. Propanol, same thing. Propylamine, same molecular weights. Again, the alcohol has the higher boiling point because the alcohol has alcohol. Oxygen is more electronegative than nitrogen, so it makes for a stronger hydrogen bond and holds the material or the molecules together tighter. Okay. So which molecule will have the higher boiling point? Would you have methanol or methylamine? Which would you think would have the higher boiling point?
Methanol.
No.
Yeah, perfect. Methanol. That's the alcohol. The OH, you have an OH bond versus an NH bond. Oxygen is more electronegative, forms a stronger hydrogen bond. Okay. Dimethylamine or water?
Water.
Water, perfect. Water has an OH group versus the NH group. Okay. Methylamine or ethylamine? Which would you think? They're both primary amines. One has one carbon, one has two carbons. I would go with ethylamine. Okay. Remember, having more molecular weight, the more size, the longer the chain, the more there is to hold it together. Okay, the more it can adhere to it. So the larger the molecule, the more it can adhere to the other chain, the other ones. So ethylamine will have a higher boiling point than methylamine. Okay. Propylamine or butane? Which one for that? Both have the same molecular weight, same size.
Propylamine.
Propylamine, perfect. We'll have the higher boiling point because butane is just all hydrocarbons, carbon, hydrogen. Propylamine does have hydrogen bonding, so it's going to hold it far tighter than the butane. Okay. Same question. Which one of those two would have the higher boiling point? Number one, number two.
Number two.
Number two, because hydrogen bonding. Two hydrogen right there. That one's a tertiary, has no hydrogen bonding. You got it. Perfect. Okay. Number two or number one, just to be different. Which one has a higher boiling point?
1.
No, higher boiling point. Oxygen versus nitrogen. Oxygen helps together tighter. This number two here would have the higher boiling point because OH forms a stronger hydrogen bond than NH because oxygen is more electronegative. So if we're comparing alcohol and amines of similar molecular weight, the alcohol is going to have a higher boiling point because the bond is going to be stronger. Okay. Solubility is going to have the same rules, okay, because hydrogen bonds allows it to be soluble in polar compounds. All amines can form hydrogen bonds with waters. That's not actually true because tertiary amines cannot. So all amines except tertiary amines, we should have said, can form hydrogen bonds with water. Remember, tertiary amines have no hydrogen attached to nitrogen, so they can't form a hydrogen bond there. Okay, my computer needs some power here. I'm limited by power cords. Plug this one and plug this one in before I lose my signal. Oh. There we go. All right. So amines up to 6 carbons long are water soluble due to the hydrogen bonding. Okay, but the longer it gets, the less soluble it becomes. Okay. Water solubility decreases as the length of the hydrocarbon portion increases. Air pumps. Okay. So as this gets longer and longer, okay, as this molecule gets longer, it gets less and less soluble. Okay, because there's more hydrocarbon part than there is hydrogen bonding part, and it gets less soluble as it goes. Okay. So there's your hydrogen bonding. As you increase the length of these chains, it's going to be less soluble because it's going to take more of the effect away from the hydrogen bonding. Okay, you can see how the hydrogen bonds works with less than 6 carbons attached to it. Primary amine is going to be aliphatic Okay, aliphatic is just your long chain hydrocarbon. Okay, you find the parent compound, the longest continuous carbon chain, just like we've always done, that contains the amine group. We've done it with ketones, contains a carbonyl group, etc. Okay, you drop the E of the parent name. So like if it's propane, you drop the E and you add amine. Okay, that's all there is to it. You drop the E and add amine. You number the parent chain to give the amine group the lowest possible number. So if we had propane, if it was amine with a nitrogen on the end, it would be propane, propanamine. Okay, you drop the E and add amine. Okay, you name and number all the substituents like we usually do. Add number 4 to the chlorine group, whatever we name that, or a methyl group. Same, all the rules are exactly the same, except we're dropping the E and adding the group amine. So here's our primary amine. Okay, how many carbons do we have? Just one, right? So this is methane. Drop the E, methane, amine. That's it. Okay. Methane, amine. We drop the E and added amine. Okay. This one here. How many carbons do we have? Longest carbon chain. We have 3 carbons. So propane. Now you got to be careful now. Guys, this would be 1 propanamine, because you could be, the nitrogen could be attached here or here. It was attached here, it would be 2 propanamine. So you got to tell me where it's attached at. You can't just look at it and say, oh, that's propane, drop the E and add amine. You got to let me know where that nitrogen is attached. Everybody see the difference? Okay. If you attach it here, it would be 2 propanamine, but this is 1 propanamine. It tells you it's an amine group. It tells you there's 3 carbons, and it tells you the amine is attached to the number 1 carbon. Okay. And let's look at this one. Longest carbon chain. Okay. Longest carbon chain with the amine attached to it. Okay. And we're going to give the amine the lowest possible number. So we're going to number from right to left rather than left to right. So this would be 1, 2, 3, 4, 5. Right? So the name for this one would be, this is pentane. It's 5 carbons. So it would be pentane amine, and it's at the number 2 position. So it'd be 2 pentane amine. Is that making sense? Sort of?
Yes.
All right, perfect. Now, secondary and tertiary amines. A little bit different here. Those are primary amines. We add an N to let people know we're going to name a different part of the amine group now. So if we add 1 N in front of the name, it's a secondary amine because it means there's an extra alkyl group attached. If we add 2 N's in front of the name, it means it's a tertiary amine. It means there's 2 extra alkyl groups attached. Okay, so we're going to add the N to it. So now we have 2 groups attached to it. Okay, we're still going to name the original one. Okay, I name them. I usually go in by size. So we'll take the largest one and put it ethane amine, and we got an ethyl group attached to it. So it'd be N ethyl ethane amine. Okay, so N ethyl ethane amine. So here's your amine. Here's your ethyl. This is one of the, it doesn't matter which group it is, but let's say that's this one. And then this is the other ethyl group. So it's a constituent. And the 1 N here tells us there's 1 additional attachment to the nitrogen. Okay. So that's what that N means in the front. And then we name the other one as a substituent. And then this is the original name. We drop the E and add amine, same as before. Okay. So for secondary or tertiary amines, the prefix N-alkyl is added to the name of the parent compound. Okay. So we name this one we would have N because we have a second one here. Okay, we have a methyl group attached, and then an ethyl group attached, and then an amine. Okay, so we have N methyl ethanamine. I just go in order of size. The smallest one comes first. So I'll let the largest one be the last one, but it's, you could go by no alphabetical order too. It doesn't make any difference. Okay, because it's going to be the exact same compound. So the N tells you there's two things attached. There's an extra one attached. Methyl tells you what your substituent, and ethane tells you there's two carbons, which are the main group, the main one attached to the nitrogen. Now, why didn't I have to put a number on this one? Because it'd be the same thing no matter where it's attached. If this nitrogen attached to this carbon, it would still be the number one carbon. It'd be the exact same thing. So I didn't have to include the number. Okay, let's look at this one. Now, this is a tertiary amine. All right. So how do I name this thing? We would put an N, so two N's, and I have two of the same groups attached, so dimethyl. Those are your attachments, and then name this rest of the compound. One carbon, methane, drop the E, add amine. NN dimethyl methane amine. So NN dimethyl methane amine. This tells you there's two additional attachments to the nitrogen. This tells you the attachments are di, which means two methyl groups. This tells you it's going to be an amine, and the other group we're looking at is methane, which is one carbon. Tells you everything you know right there. Determine the systematic nature of the following amines. Okay, so sometimes it helps to draw the structure. It helps to go like, this is N, we have a CH3 group here, we have a hydrogen, and we have a CH3 group here. Now, why can't the CH3 group be attached to the hydrogen? You can't. Hydrogen is a terminal, remember? Hydrogens only have a single bond. So once you say hydrogen, you know its terminals have to start over the other side of the nitrogen. All right, so sometimes it helps to draw the structure form and take a look at it. It makes it less confusing. All right. So what do we got? We've got one attachment besides the original one. So we have an N. Okay. We have a methyl attachment to it. Okay. So N-methyl. Okay. And then the other one is methanamine. So it'd be N-methyl methanamine. Again, yeah, the one N tells you there's an additional attachment. Oops, my computer froze up. Let's see what we got here. Okay, that's what we did. N-methyl methanamine. And we're not going any farther. Oh, there we go. Now it worked. All right. I wonder why I took so many spaces. So now we've got group attached. Here's our nitrogen. We have a hydrogen and CH3. Three groups attached to it, right? We have one hydrogen, one carbon group, and one 3-carbon group. Okay. So we put, how many N's are we going to put in front of it? We're going to put one N because there's one additional N. And we have a methyl group attached. So N methyl. Okay. And the other one is 3 carbons. Okay. 3 carbons is propane. So propane amine. Okay. You got to tell it's where it's attached there. So N methyl propane amine. Right? Again, tells you that there's one extra attachment, tells you it's the methyl group, that's your attachment, tells you it's an amine, and that it's propylamine is attached to it. It's 3 carbons. Okay. Let's try the other one. Okay, now we got a tertiary amine. There's three things attached. So we know it's going to start out as what? It's going to start out as NN. Okay, because there's two additional attachments to the original. And we've got a methyl group, we've got an ethyl group, and we got a propyl group. Okay. So NN would be, we have NN methyl, ethyl, those are your attachments, propanamine. Okay, so here's your NN, your two attachments. You have a methyl group and an ethyl group. So NN methyl ethyl, it's an amine, and then propanamine. Okay. And we've got this is a primary amine. Remember, primary amines, we don't include the ends, right? Because there's no additional attachments to the nitrogen. It's just the one group. So how many carbons do we have in our longest carbon chain? 1, 2, 3, 4, 5, 6. And we're going to number it left to right or right to left. We're going to number it left to right to give the amine group the lowest possible number. And we tell it where it's at. So we got 3. And this is, what did I say, 6 carbons? Hexane amine. Okay. We know it's a primary amine because there's no ends in front for additional groups bonded to the nitrogen. Okay. We know there's 6 carbons, hexane, and we know it's an amine. And only one bond to it. That's at the number 3 position. Okay. This one is a tertiary amine. Okay. Okay. So we got group here, group here, group here. Okay. So how's it going to start off? It's going to start off with N, N. Okay. And then we're going to have, what do we have? We have 2 ethyl groups. So diethyl. Okay. And then we got 3 carbons here, which is propane amine. So NN diethyl propanamine tells you it's an amine. It's a 3-carbon chain. There's 2 other chains attached to the nitrogen, and both of them are ethyl groups. That's how the names are. That's how nomenclature goes with it. Okay. Naming aromatic amines. Okay, a lot of aromatic amines are your medicines. Okay. So several aromatic amines have special IUPAC approved names. So it means of benzene, like aniline. Aniline is benzene ring with an NH2 on top of it. Okay? That's just the background of the name for it. Okay. And toluidine. Toluidine is an NH2 group and a methyl group attached to it. And remember ortho, meta, para positions. Okay. It's in the ortho position, it's 1, 2. If it's in the meta position, it's 1, 3. If it's in the para position, it's 1, 4. Okay. So common names of amines, that was your systemic name, your IUPAC name. You can also use it called common names. Okay. Attached in the alphabetical order or by size. We add the word amine. The name is continuous, no space between the group. Okay, so you have CH3 and H2. Remember that was methylamine. Okay, or the IUPAC name we did was methane. We dropped the E and added amine. Okay, the common names. Okay, you're going to name the substituent methylamine. Okay. So we're only going to do it for methyl for the substituent groups. We just name it as the YL ending. Okay. The IUPAC was methanamine. When we're naming common names, we just name everything as a substituent. So it would be methylamine. Okay. This would be dimethylamine. Okay. That's again, those are common names. You look at 2CH3, you have dimethyl. The other way with IUPAC, we named it would be methyl methanamine. would be the IUPAC name of it. Okay, but common name, we just say dimethylamine. Okay. Okay. Want to guess what this one would be a common name? The IUPAC name was N-N-dimethyl-methanamine. The common name is going to be trimethylamine. Got 3 amine groups to it. That's it. Tells you tri, there's 3 methyl groups, and it's an amine. Okay. Again, primary amine here. This was what group is this? So common names just name the substituents. That's all you're doing. So it's ethyl amine. Okay. This one be methyl ethyl amine. Okay. I named you can name it either way. I named by smallest to largest group size. So it could be ethyl methylamine or methyl ethylamine. Do the same structure that you draw. Okay. Review a couple things here. The compounds are NH2, that's a primary amine. It's alkane, and then word amine. That's a systemic name, the IUPAC. This is your IUPAC. Might be used for most things. Common name would be the alkyl amine, like methylamine, ethylamine, whatever, propylamine. Okay, so this would be CH3NH2. That would be methyl. The systemic name would be methane amine. The common name would be methylamine. Okay. If you had 2 carbons attached, okay, now you would have an ethyl. So the systematic name would be ethane amine. The common name would be ethyl amine. Propane, 3 carbons. Propanamine or propylamine for the common name. Okay, now we have a secondary amine. The systemic name would be N, because there's an extra attachment now. So it'd be N-methyl-methane amine. Okay, N-methyl-methane amine. You're naming each part. The common name would be dimethylamine. There's just 2 methyl groups attached. What I did, okay, there we go. Again, that's a secondary amine. So the systematic name would be N-methyl-ethane amine, because there's the 2 carbon group there. So N-methyl-ethane amine. The common name would be methyl ethyl amine. Making sense? Got one more. Amine, a nitrogen with 3 methyl groups attached to it. A tertiary amine. The systematic name would be N-N dimethyl methane amine. Okay, so N-N dimethyl methane amine. The common name, right, would be trimethyl amine. 3 methyl groups attached to an N. Okay, so that's a real good slide. This one here, just keep this one in mind right here, how you're naming between the systematic name, which is IUPAC, and your common name. Okay, so N-methylmethanamine, okay, trimethylamine, is used by the German cockroach. Cockroach is always so much fun. As a communication pheromone, it's a very simple compound, easy to produce. Draw the structure, formula, and give the common name of the amine. Okay, so N-methylmethanamine. So we know it's an amine. Do we know it's a, how do we know if it's a primary, secondary, tertiary amine? And how do we know?
It's secondary.
Secondary, because
One
there's an
N. Yeah.
Perfect. Perfect. That's exactly right. That's great. So we got an amine, so we got a nitrogen, and we know it's a secondary. So we got 1 hydrogen. Okay. And we got a methyl group, which says right here, it says methyl is our attachment. So one attachment is CH3, and another attachment is methane also. It says methane amine. CH3. That's the structure formula right there. CH3 and CH3 and a hydrogen. Now the common name, it says it wants the common name of this thing. What would the common name be? What's attached to it? Common name would be what?
Dimethylamine.
Exactly. Very good. It'd be dimethylamine. So there's our compound. Okay, that's what we drew. And it's dimethylamine for the common name. So again, we know it's an amine with the nitrogen. And we know it was methyl, where one had, we had the one N, and then methane amine, which is dimethylamine. Okay. Name each of the names using systematic, which is your IUPAC, and common nomenclature. So name this thing. Let's do the systemic name first. So when you do a systemic name, you have to determine whether this is a primary, secondary, or tertiary amine. So that's our first step when we do with amines. So what is this? Primary, secondary, tertiary?
Is it primary?
That's primary. Perfect. You're right. Nitrogen has two hydrogens attached here. It's primary. So only one attachment is nitrogen. So there's no N's. Okay. So we're going to name it according to what it is. There's 1, 2, 3, 4 carbons. Okay. And the nitrogen's attached at the number 2 carbon. So we're going to call it 2 butane. Drop the E and add amine. So 2-butane amine. The common name, you look at that, we're named by the attachment. This would be 2. And we're going to name the chain as an attachment now. So a YL ending, like a methyl, ethyl. This is a butyl group. So 2-butyl amine. So this is a systematic name. This is the common name. Okay. So 2-butanamine, systematic name, and 2-butylamine for the common name. Okay. And here's another one. Primary, secondary, or tertiary? And H2 is primary. So no N's in front of it. And then this, remember, this was a tert butyl group right here, these 4 carbons. So it would be tert butyl, which is a tertiary butyl is what it stands for. Okay, butyl amine, that's the common name because we named it substituent. Or it would be tert butane amine for the systematic name. Okay. Or you can name it according to the they broke it down. Right. So you can recognize this as a tert butyl group right here and name it according to what we just did, or you can recognize it as 2-methyl 2-propanamine, because here's propane. I got too many lines drawn here. Let me get rid of some of these lines. Okay, I'd accept like tert butyl is acceptable abbreviation for this group, or you can name it according to, here's your longest carbon chain. So it's propane. At number 2, you have a methyl group. And at number 2, you have an amine group. So it'd be 2-methyl 2-propanamine. Okay. That's a systematic name. Or the common name would be 2-methyl 2-propylamine. You name it as a substituent. Okay. 2-methyl 2-propylamine. And again, I'd accept that as a tert butyl also. So either one of those is fine. Okay. Now, what amine do we have here? Primary, secondary, tertiary?
Secondary.
Secondary, perfect. Okay. So we're going to name this thing here. We're going to start with an N for a systemic name. Okay. And then we got N, we have a methyl attached. N-methyl. And then this is a butane group, has 4 carbons. Okay. And it's attached to the number 2 carbon. So N-methyl 2-butane amine. That's the systematic name, the IUPAC name. Common name would be methyl 2-butyl amine. Tell you where it's at. So N-methyl 2-butanamine. That's your system, like we said before. That tells you it's secondary. That tells you one attachment is a 1-carbon methyl group. It tells you the other attachment is 4 carbons. Okay, with that number 2 being the amine group attached. So N-methyl 2-butanamine. Okay, and we said the common name was methyl 2-butylamine. Again, we named this as a substituent. We don't name it as the main group. So we put butyl as our substituent. So you have a methyl group attached, and then we have butyl 4-carbon chain. At the number 2, there's an amine group. Either way, you give the same compound, whether it's N-methyl 2-butanamine or methyl 2-butylamine. It's going to be the same exact compound. All right, this is a tertiary amine. Tertiary amines are going to be named systemic name. We're going to have 2 N's. N. We have a methyl and an ethyl. So NN methyl ethyl. That names this, that names this. And then we have to name this one. This is propyl, there's 3 carbons, and it's attached to number 2 position. That's an L, not a. Make that a little clearer. There you go. Methyl ethyl. And then number 2, propyl, for systemic name propane amine. The common name would just be methyl ethyl 2-propyl amine. Okay, so our systematic name was NN methyl ethyl 2-propanamine. There should be a dash right in there between the 2 and the P. Remember, there's commas between numbers and there's dashes between numbers and letters. Okay, so NN methyl ethyl 2-propanamine. The common name we said was methyl ethyl propyl 2-propylamine. I'm sorry, methyl ethyl 2-propylamine. Okay, so it says methyl ethyl 2-propylamine. Draw the complete structure form of each one compounds. All right, now you get to draw it. Okay, so 2-propanamine. Propanamine is, propane is 3 carbons. So put your 3 carbons, and it's amine attached to the number 2 carbon. So find your number 2 carbon and put an amine group there. So CH3, CH, CH3. 2-propanamine. Okay, this is 1, 2, 3. Propane is your longest carbon chain. Your amine group is attached to the number 2 carbon. Okay, the common name, if you want to do the common name, would be 2-propyl amine. Just name the substituent. All right, 3-octanamine. Octanamine is how many carbons? Octane is 8. So you put 8 carbons. And at number 3, you would put an amine group. Okay. And then everything else is filled with hydrogens. So this is your 3rd carbon. So that's 3-octanamine. The common name would be 3-octyl amine. N-ethyl 2-heptane amine. Okay. You see the 1 N in front of it, you know it has to be a secondary amine. So you got 1 nitrogen and you got a hydrogen bonded to it. Okay. You have 1 ethyl group CH3, CH2, that's your ethyl group. And then you got a heptanamine group. But the number 2 is going to be the carbon bond to it. So 1, 2, and then you got 5 more carbons. You can write them up this way. 1, 2, 3, 4, 5, 6, 7 carbons. And fill those in with hydrogens. CH3, CH2, CH2, CH3. Okay, so it tells you it's a secondary amine. Tells you there's 7 carbons. Okay, at the number 2 of the heptane of the 7 carbons, there's an amine group attached, and there's an ethyl attached at one of the other ends. Okay, so there's your amine. Okay, there's your ethyl group, and here's your heptane group at the number 2 carbon. Okay. 2-methyl, 2-pentanamine. Okay. So 2-methyl, 2-pentanamine. Okay. So you have the pentanamine is 5 carbons, right? So where are we at? So 2-pentanamine is 1, 2, 3, 4, 5 carbons. At the number 2, there's a methyl group. And at number 2, there's an amine group. So it would look like that. Pentanamine, 5 carbons. At number 2, there's a methyl. At number 2, there's an amine group. Okay. That's a long one. 5-chloro, 5-iota, 1 nonane amine. Okay. So you know it's an amine. Okay. You know it's a primary amine because only 1 attachment there. You know nonan is 9 carbons. So you draw 9 carbons.
She told them last night.
Okay, 9 carbons. At number 4, there's a chlorine group. At number 5, there's an iota group. And at the number 1 carbon, there's an amine group. Okay. So you draw 9 carbons. Number 5, there was an iodine. Number 4, there was a chloro group. And right at the first carbon, number 1, was your amine group.
Break time in there.
Almost. All right. So far, so good. All making sense. We're almost ready for a break here. So let's do, probably do this one, then we'll take a break. So NN, diethyl, 1-pentanamine. All right. So NN means it's a tertiary amine. It means there's 2 extra attachments, 2 more attachments to nitrogen than just the normal 1 primary. So it says there's a nitrogen group and there's 2 ethyl groups attached, diethyl. So CH3, CH2, CH2, CH3, there's your ethyl groups. And then 1 pentanamine. So from number 1 of the 5 carbon, there's an amine group attached. So we have 5 carbons. CH2, 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 CH3. Okay. So here's your nitrogen. There's your diethyl, 1 ethyl, 2 ethyls. And here's your pentyl group. Okay. And it's at the number 1 carbon. That which tells it where it's attached. A lot of students forget to put this number right here. They just go the ethyl, methyl, pentyl. They forget to tell you where it's at if it's at the number of carbon. You've got to tell you where it's attached to. Drawing structure formula for each of the following compounds. Okay. Methyl, diethyl amine. Okay. Common name rather than it's a systematic name. So it tells you there's a methyl group and there's 2 ethyl groups and it's an amine. So that tells you it's a tertiary amine. So you have your amine is N, and you have a methyl group attached, and you have 2 ethyl groups attached. So methyl diethyl amine. Okay, all right. We get some of that writing out of the way there. Okay, so there's your methyl group, and then your 2 ethyl groups are attached to your amine. It's a tertiary amine. 4-methyl pentyl amine. Okay. So again, working backwards, we always do organic chemistry. There's an amine and it's pentylamine. This is a common name. So pentyl is 5 carbons. There's your 5 carbons. And number 4, there's a methyl group. And 4-methyl pentyl amine. They should have a number 1 in there, but I'm pretty sure it's 4-methyl 1-pentyl amine. Okay, what it should say, because it could be at number 2 or 3 position also. So there's 1, 2, 3, 4. So your 4-methyl group, and number 1 there is your amine group, and that's a primary amine. Okay, wrong computer. So N-methyl aniline. Now remember, aniline, okay, is benzene with an NH2 group on it. Okay, so it's 1 attachment to the nitrogen. So it's a secondary amine. Okay, so aniline is your benzene ring. Okay, with NH2. Okay, that's aniline there. Now it says it's a secondary amine. It's got a methyl group attached to it. CH3 and an H. So that would be N-methyl aniline. Okay, where I right where I drew it. Try to draw it out of the way. Okay, so this is aniline right here. Okay, and this tells you there's one extra attachment to the nitrogen, and it's a methyl group. Okay, so N-methyl aniline. Tri-isopropyl amine. Okay, so it's a common name. There's 3 isopropyl groups attached to a nitrogen. So this is a tertiary amine, and every one of these is going to have CH2. Remember, isopropyl is a 3-carbon chain with it attached to the middle carbon. So C, and the same thing here, CH, and then 2 CH3s. Okay, that's tri-isopropylamine. So isopropyl, if you remember isopropyl, that's a propane. It's a substituent attachment attached to the middle carbon of each one. So 3 the exact same thing, 3 propane groups attached to the middle carbon. So tri-isopropyl, 3 isopropyl groups, amine. It's a tertiary amine. M or methyl tert-butylamine. That was like you had last time. We did the tert-butyl group, how you can name it. Okay, so it's an amine, has a methyl and a tert-butyl group. Okay, so there'll be 2 attachments to it. So there's your amine. Put it over here, it's out of the way. Hopefully it's out of the way. And there's a hydrogen, there's a methyl, and there's a tert-butyl group. Tert-butyl group is CH3, CH3, CH3. Okay, this is a tert-butyl group right here. Okay, it's 4 carbons, butyl, and they're each attached to a tertiary carbon. Okay, so it attaches right to the center there. That's your tert-butyl group. That's T-butyl right here. Okay, there's one of those. There's a methyl group, which is right here, and it's an amine, which is right here. Okay, so that's methyl tert-butyl amine. Ethyl hexylamine. Okay, again, it should say ethyl 1-hexylamine to be accurate. I'm pretty sure that's what they want. But it's an amine. It's got 2 attachments. It's got an ethyl attachment and a hexyl attachment. Ethyl is 2 carbons. Hexyl is 6 carbons. So 2-carbon attachment, 6-carbon attachment, and it's an amine. So here's your amine. It's a secondary amine because there's two attachments. The other one's a hydrogen. Here's your ethyl group. Here's your hexyl group. Okay. And again, it should say one hexylamine to be accurate. The ethyl group doesn't matter because either one of these attaches to is still going to be the same. But that's ethyl hexylamine, the common name. Naming aromatic amines. Aromatic amines are ones with benzene rings, like aniline we just saw. Okay. Several aromatic amines have special IUPAC approved names. Okay. Amines of benzene is named aniline. That's what we covered just a little while ago. Aniline is one of them. So it's a benzene amine. Okay. As additional groups are attached, they're named as substitute derivatives of aniline, just like we did before. We put an N from it and tell what's attached to aniline, to the nitrogen. Okay. So this is aniline. That's the name given to it. And it's benzene amine. It's a benzene group attached to an amine group. Okay. So that's aniline. So when a methyl group is added to the aromatic ring structure of aniline, it becomes toluidine. When we put a methyl group on it, so we put a CH3 group here, or here, or here. And this would be ortho, meta, or para, or 1, 2, 1, 3, 1, 4 position. Okay. But when we put a CH3 group, then it becomes toluidine. So this compound here is ortho toluidine. Okay. Because this is in the ortho position. This is going to be meta toluidine. It's in the meta position, or the 1, 3 position. And the other one is going to be in the para position, 1, 4. Okay. And it's going to be P, or para toluidine. Okay. So use the structure of aniline provided and draw the complete structure form of each of the following amines. N-methyl-aniline. Okay, aniline was benzene compound, right? With an NH2. And it says this, now we got one attachment on that extra, and it's a methyl group. Perfect. Just like that. Okay. So one of the hydrogens you replace with the methyl group. So aniline is a benzene ring with NH and N on top. Okay. And we have one extension on it, one attachment, N-methyl. Okay. And dimethyl aniline. So let's draw aniline. Aniline is just amidobenzene. Okay. And now we got both hydrogens are substituted, because this says one hydrogen substituted, this says the other hydrogen substituted with to the nitrogen. So it's dimethyl. So there's two methyl groups attached to it. Okay. That's what it looks like. And dimethyl. And this is aniline right here. Okay, and ethyl aniline. Again, you'll draw aniline. And one of the hydrogens will be replaced by an ethyl group. There's one in there. So there's your hydrogen and there's your ethyl group. Okay. Again, and ethyl. There's your ethyl, and this is aniline. And isopropyl aniline. Okay. Again, you draw aniline. You draw your benzene ring, your nitrogen. One of the hydrogens being replaced. Okay, is replaced with an isopropyl group. Isopropyl group is 3 carbons bonded to the middle carbon. And the other is hydrogen. So N isopropyl aniline. Okay. Again, here's your isopropyl group. Bonds to the middle carbon of propane. And this is aniline. This is aminobenzene. All right, IUPAC nomenclature. For primary amines, the prefix amino and the number designates the position of the amino group on the alkane parent chain. The N uses the N prefix, that's what we did before. Okay, so we're going to do the IUPAC name now. Okay, IUPAC name is, this is primary amine. Okay, so this is 2-amino propane. IUPAC names are very rarely used nowadays. Mostly it's the systematic and the common names. But its prefix, it starts with amino and then tells you what compound it is. So it's backwards from everything else we've done. So it tells you, but if you see it, you can still recognize what to draw. You can still recognize what it is. Because the number 2 compound of propane, there's an amino group attached. That's exactly what you have here. Right? And this one, okay, this is going to be a secondary amine because there's 2 things attached. We have a methyl group and we have an isopropyl group, and then we have our hydrogen. Okay, so we have N, okay, methyl, tells you there's a methyl group, that's this one right here, and 2-amino propane. So this is your propane, okay, and attached at the number 2 position. Okay. You could have wrote isopropyl, be the same thing. Isopropyl is the same thing as 2-amino propane. So the N tells you there's an additional attachment, and it's methyl. The 2 tells you the position where the amino group attaches to the propane carbon chain. Did I get that? Is that all that? Okay. So N-methyl 2-amino propane. All right, medically important amines. Amines are a lot of our medications that we use, both legal and illegal, are amine-based. Right? Amphetamines. Okay, speed. Amphetamines, they stimulate the central nervous system. They key you up. Okay, they're uppers. This is amphetamine. That's what it looks like. Benzene ring with a primary amine group. Okay, that's amphetamines. It's 1-phenyl, 2-propane amine. Okay, here's your 3-carbon chain. Okay, at the number 1 position, there's a phenyl group. Remember, PHNYL is the attachment. OL is the OH group on top of a benzene ring. So 1-phenyl, this is your number 1 carbon, your number 2 carbon, your number 3 carbon. Okay, so 1-phenyl, 2-propane amine. 3 carbons, the number 2, again, they forgot the dash in there. Okay, so propane amine. That's amphetamine. Okay, this one here. Okay, this one is methamphetamine. Okay, well, a methyl group has been added. So now you've got a secondary amine. That's why you have this extra N here. Okay, and it's a methyl group. So N-methyl, 1-phenyl, 2-propane amine. You've added a methyl group. You place 1 hydrogen methyl group. That is methyl. Okay. That is methamphetamine. Rather than amphetamine, now it's methamphetamine. Just adding a methyl group to it. Analgesics. Analgesics are pain relievers. Anesthetics are pain blockers, are nitrogen compounds. Okay. This is Novocaine. Okay. Anybody's had dental work done knows what Novocaine is. Okay. This is an amine. Okay. There's your NH2 group. Okay. This is a ester, right? Compound there with ammonia on there. That's Novocaine. This one here is Demerol. We give a lot of patients Demerol by injection. Right? Demerol again. This is now Novocaine is a primary amine. Demerol is what? What type of amine? Demerol is a tertiary amine. There's 3 bonds to it. It's a cyclical amine, okay, but there's 3 bonds to nitrogen, so it is a tertiary amine. There is no hydrogen attached to that nitrogen. Okay. Amphetamines, like Benzedrine, ephedrine, stimulate the central nervous system. That's what amphetamines do. Okay. They elevate blood pressure, elevate the pulse rate, and are used to decrease fatigue. They're uppers. Okay. They have been used to treat depression and epilepsy. Amphetamines also been described as diet pills, okay, because they decrease the appetite. They're not used to prescribe as diet pills anymore. Amphetamines are very addictive. Okay. They're useless controlled by federal law because excess use of amphetamines can cause paranoia and mental illness. Okay. Many of the medicinal amines are analgesics. Analgesics relieve pain, and anesthetics are your pain blockers. Novocaine, okay, uses local anesthetic. Demerol, very strong pain reliever. We saw the structure of both of those. Decongestants shrink the membrane lines in nasal passages. That's what dries up your nasal passages when you're stuffed up. Okay, this is ephedrine. Ephedrine is used. Sudafed, over-the-counter products like that is used as a decongestant. Ephedrine can also make. Okay, can also make meth, crystal meth. This is the starting material for meth labs. Okay, and it's ephedrine. Okay, this is pseudoephedrine. It's also used as a decongestant. You can see the differences. These arrows mean it's coming out. These arrows mean it's going into the board. So it's like three-dimensional picture here. But this is a secondary amine. This is a secondary amine. You can see very similar structures to it. Okay. In fact, the only difference is the cis-trans relationship. Okay. This one's on the coming out. This one's going in. Okay. Everything else is exactly the same. Just how it's positioned in three-dimensional space. Okay. And this was a neosynephrine. There's an extra OH group under that one. Sulfa drugs. Those are the first chemicals we used up before penicillin to fight infections. They also come from amines. Okay. This is your sulfa drug right there. The S group is on there. This is sulfanylamide. Sulfanylamide, I'm sorry. Okay. Ephedrine, okay, is a stereoisomer of pseudoephedrine and phenylephrine, also called neosynephrine. Okay. There can decongestants using cough syrup and nasal sprays. They drive your nasal cavities, nasal membranes. By the shrinking of those membranes that line the nasal passage, they relieve the symptoms of congestion and stuffy nose. These compounds are very closely related to 1-dopa and dopamine in the brain. Okay, those are key compounds that function in the central nervous system. Many studies have restricted the sales of products containing ephedrine and pseudoephedrine, and many drug store chains have moved these products behind the counter, so people have to sign when they buy it, so they can't buy multiple amounts of it. Okay. The reason is that either ephedrine or pseudoephedrine can be used as starting material in the synthesis of methamphetamines. Okay. That's what we use in meth labs out here. This is ephedrine. In response to this, pharmaceutical companies are replacing ephedrine and pseudoephedrine, okay, with phenylephrine, which cannot be used as a reactant in the synthesis of methamphetamines. So starting to replace them. Ephedrine and pseudoephedrine are also the primary active ingredients in ephedra, okay, a plant found in the deserts of Central Asia. Ephedra is used as a stimulant in a variety of products that are sold over the counter as aids to boost energy, promote weight loss, and enhance athletic performance. So back in 2004, the FDA banned the use of ephedra, okay, these over-the-counter products, after reviewing 16,000 reports of adverse side effects, including nervousness, heart irregularities, seizures, heart attacks, and 80 deaths, including that of Baltimore Orioles pitcher Steve Betzler, age 23, if you remember that. However, a federal judge in Texas ruled that FDA had failed to prove that ephedra is dangerous at doses of 10 milligrams or lower, opening the way for the sales of ephedra containing herbal remedies. So now in Texas, they can sell that as herbal remedies with ephedra in it. Now you get reactions involving amines. Aliphatic amines, okay, one with carbon-carbon chains on it, okay, are prepared by reduction of amides. An amide, we haven't done this yet, but an amide is a carbonyl group bonded to the nitrogen. Okay, so when one of the groups attached to nitrogen has a carbonyl group, and then you have 3 different groups attached here. Okay, when there's that carbonyl group attached to the nitrogen in between one of the R groups, that's called an amide instead of an amine. Okay, when you have that. Okay, reduction is adding hydrogen, oxidation was adding oxygen. So we're going to add hydrogen across this double bond, get rid of the oxygen, and this carbonyl group is going to become CH2. So we're going to add hydrogen across that double bond. We're going to lose the OH and get hydrogen on both sides of the carbon. That's the reduction of an amide to form a amine. Okay, that's how amines are formed. So this is an amide because it's a carbonyl group, and this is an amine because it's just 3 groups attached to nitrogen. Okay, R2 and R3 may be hydrogen atoms or any organic group. Okay, so aromatic amines are prepared by reduction the same way. Okay, aromatic amines into the NO2 group. Again, you're replacing that with hydrogen. Remember, adding hydrogen or losing oxygen is reduction. So here we're losing oxygen and we're gaining hydrogen. This is reduction. So NO2 goes to NH2. Nitro compound, and this is a primary aromatic amine. Okay, so if R2 and R3 of those products are hydrogen atoms, the product's going to be a primary amine. Okay, so here's your attachment. This is what makes it an amide here to the nitrogen. Okay, if that's a primary, okay, if that's a primary amide here, okay, if R2 and R3 are hydrogen atoms, then you're going to get a primary amine being formed because you're adding hydrogen to replace that oxygen, H above it and H below it. Okay, so this is ethane amide. Okay, 2 carbons. We'll learn how to name those in just a minute. And this is, okay, ethane amine. Amine and amide are the differences when you have the carbonyl group. Okay, if either of those are an organic group, the product will be a secondary amine. Okay, so now instead of this, we have a methyl group here. When we replace this with hydrogen, this becomes a propyl group. This becomes a methyl group. This becomes a secondary amine with reduction. Okay. Okay. So if both of these were hydrogens, right here, this would be a primary amine. If one of those is an alkyl group, an R group, then it's going to be a secondary amine. Okay. So this is N-methylpropyl, N-methylpropane amide. Again, it's an amide because there's a carbonyl group attached between the N group and the R group there. So it's N-methylpropane amide. It would be N-methylpropane amine. Okay. If both R groups are acyl compounds, organic compounds, the product's going to be a tertiary amine. Okay, so if both R groups are hydrogen, it's going to be primary. If one of the R groups is R group, a carbon group, it's going to be a secondary. If both R groups are carbon groups, it's going to be tertiary. Okay, so here we have an amide because nitrogen, and we're going to see this pattern a lot in biochemistry because that's how amino acids are. Amino acids are amides. The nitrogen with a CO group in between there. So this is 3 connections. Every one of these 2 are now replaced with R groups. Okay? So we're going to reduce it. So we're going to put hydrogen. We're going to make that CH2. We're going to lose oxygen. Replace those with hydrogen. Okay? And now we're going to get 2 methyl groups attached. What we started with here, and then CH3CH2. Okay? So this would be NN dimethyl ethane amide. So the amine, it tells you the ethane amide, that means there's two carbons associated with the carbonyl group. Okay, and then there's dimethyls attached to the nitrogen, two methyl groups. Okay, so this would be NN dimethyl ethane amine. NN dimethyl ethane amine. Okay. Amines is bases. Amines are weak bases. Okay, they're because they accept a hydrogen. Okay. In other words, if you have ammonia, ammonia is a base. Here's ammonia, 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 and you have those two free electrons above it. Okay. So a hydrogen atom can attach here and give you NH4 plus, a positive charge. Okay. And that's ammonia, the ammonium ion. Okay. So the lone pair of electrons of nitrogen can be shared with a proton from water. And then it takes water. Remember, water is HOH. Okay. If we take this proton and it's attached to it's attracted to the electrons from the ammonia, okay, we're left with OH minus. So if you produce OH minus, that's a base. So ammonia is a base because of that reason. Okay, it's an alkyl ammonium ion is produced. That's your ammonium ion. If there's R groups attached, and it's an alkyl ammonium ion. Hydroxide ions are also formed, making the solution basic, because when H is pulled off of water, the OH minus is left. Okay, so here's your primary amine. Okay, got it. Okay, there's your water. Okay, the hydrogen goes to here, OH minus gets released, and then you get this alkyl ammonium ion. Okay, so there's your amine, and there's your alkyl, which means there's an R group attached, ammonium ion. Okay, and then you get your hydroxide ion released, causing it to be a base. Okay, so example amine in water, this is methylamine. Okay, or methanamine. This is methylamine here. Okay, reacts with water. The hydrogen is going to be attracted to here, includes OH minus, and it's going to give you an extra H there. It's going to extra bond to that, giving you ammonium ion. So this would be methyl ammonium ion. It's an ion because it has a charge. Okay, so methyl ammonium ion. Okay, so when nitrogen has 4 bonds to it, okay, it's an ammonium ion, and the methyl tells you there's 1 methyl group attached to it. And then you have your hydroxide ion too. You can also have neutralization. Ammonium forms salts by accepting a proton from a strong mineral acid, just like from water. Like HCl can attach the H, and they can form salts, just like carboxylic acids did. Okay. So again, here's your R group, okay, and HCl. The H bonds to the top free bonding electron pairs there. Okay, and gives you an ammonium ion. Okay, and chlorine is being released. Okay, that's a salt. It's an ammonium salt. So this is an amine, and hydrochloric acid, and this is the alkyl ammonium salt. It's alkyl because there's R groups attached to it. So again, this is your same example we looked at before with water. But this hydrogen is now going to come over here and bond there. And that's going to give you your ammonium salt complex. So this is methylamine, hydrochloric acid, and this becomes methyl ammonium chloride. Just like you would have sodium chloride, barium chloride, calcium chloride. This is methyl ammonium chloride. So this is methyl, this is ammonium, this 4 bonds to nitrogen is ammonium. So that's ammonium chloride. That becomes the metal now. Okay. Alkyl ammonium salts that we were just talking about. When we have the name amine salt replaced by the suffix amine with ammonium. So we're replacing ammonium, we're replacing amine with ammonium when we form that extra bond from hydrogen to that nitrogen group. So we add the name of the ion, anion, Converting amines to salts makes insoluble amines soluble. Because you have this amine, okay, that's not soluble in water. Now we're making it with positive charges, makes it polar. Once you have the salts are dissolvable in water. So a lot of our medications, we put them in forms of amine salts to deliver them. Okay, that way they dissolve in the bloodstream and they can get to the places in the body that we need. Okay, so here we have an amine, right? This is propylamine or 1-propane amine. Okay, propylamine, 1-propylamine. Okay, hydrochloric acid. Okay, so the hydrochloric acid, the H, went to here to form your amine. So here's your amine group, ammonium. Okay, so it's propyl ammonium chloride. Okay. Okay. So the only difference between the ammonium ion, okay, and the amine salt is one of these hydrogen. This is ammonium. All 4 of these are hydrogen. If one or more gets replaced with an R group with a carbon compound, then it's an ammonium salt. Okay, it's an acyl ammonium salt. It takes on the name of whatever R group is there. So that's NH4 plus, and this is the amine salt because it's going to have a positive charge and bond with the anion in solution. Okay, a lot of important drugs are amines. They're administered as the alkyl ammonium salt to make them soluble in polar fluids like blood, aqueous solution, and body fluids. Okay, so a lot of our drugs are amines. We turn them into alkyl ammonium salts, has the same effect on the body, but now it's polar. It can be delivered to the body fluids. Okay, complete response reacts by solving for the missing product. Okay, what's it going to form? Okay, think about it just for a second. Remember, on ammonium, there's 2 non-bonding electron pairs. So the hydrogen is going to bond there.
It's called Heartland.
So it's going to form
Horses better that have problems.
NH2, and you get another hydrogen here. So NH3 plus and Br minus. So it's going to form the ammonium salt. Okay. So there you get the salt. You get NH4 plus being formed and Br minus. Okay. It forms the alkyl salt because those non-electrons pull that hydrogen here and then you get the Br minus in solution. Okay. What would this form? Now remember, these are bases in solution. Okay, bases accept proton and produce OH. So water is HOH. So the hydrogen attaches to the non-bonding electron pairs here, and OH minus, and then you would get the salt. You get the CH3, CH2, and CH3H, H. And you get a plus. Okay, so you get your ammonium salt. Yeah, get that out of the way for you. Okay. Just gotta remember, water is HOH, and the hydrogen attaches to the nitrogen, and you get OH minus in solution, and then you get your ammonium salt, has a charge with it. Okay, same thing. You remember, we got water is H2O, so OH minus and H plus. And the hydrogen attaches to the free bonding electron pairs on that nitrogen, giving your ammonium, the alkyl ammonium ion. So here's your 2 hydrogens that were attached to it here, and this hydrogen here comes from the water. Okay, supply the missing product again. So what's this one going to look like? Again, hydroiodic acid, the H, goes to the non-bonding electron pairs. Okay. You end up with CH3, NH. This is the H from the HI, and then H and H, and it's a positive charge. Because now there's 4 bonds on nitrogen with an extra proton, giving it a positive charge. And then you got I minus forming your salt. Okay, so that's methyl ammonium iodide. Okay. So again, here's your ammonium compound. Positive charge, and your iodine negative charge, your anion. Right, again, HBr, hydrobromic acid, hydrogen bonds to there, and now you get an ammonium salt. So we can do this to make them salts. Like I said, we can deliver these medications to parts of the body. We make everything water soluble this way. Okay. So here's our ethyl group. Here's our 2 hydrogens that were originally on there, and this is a hydrogen we put on from the HBr, and then Br minus is created in solution when the hydrogen is pulled off of it. So ammonium compounds are bases. Amines are bases because you're ending up producing OH in solution and you're accepting a proton. Remember, acids give off a proton, bases accept a proton. Okay. Diethylamine or N-ethylethanamine, either one. Okay, the nitrogen goes on there. And it's diethyl ammonium salt, ammonium chloride in this case, because it'd be Cl. So here's your chlorine that came off, and your extra hydrogen was put on there, and this is your diethyl, the same as you had before. So it's diethyl ammonium iodide, or ammonium chloride for this one. If you're gonna have base reaction, you have a neutralization reaction, because remember they're bases. If they're bases, you add an acid, it neutralizes it. So alkyl ammonium salts can be neutralized. Like salts can neutralize hydroxide ions because they can donate their proton to it. Okay. And water is formed. When you neutralize something, you usually form water. The protonated amino cation converts into an amine. So this is the backwards what we've been doing. It's the exact same reaction we just did, except we're putting everything backwards now. We're going the opposite direction. The reversal of the alkyl ammonium salt to the amine is extremely important in a lot of drugs. Okay. So this is our ammonium salt right here. Again, here's our nitrogen. Nitrogen has 4 bonds to it right here. There's 3 hydrogens and then the phenyl group with a nitro group on it. Okay. So that gives you your ammonium salt, and we react it with a base. That's going to be a neutralization reaction. Okay. Because now we can take a hydrogen from here, combine it with the OH, okay, and form water. And the chlorine can now form with the sodium, and we get salt water. Okay, so now we get NaCl formed, okay, for the Na right here, with the chlorine extra, and then water formed by adding that proton, and we regenerate our amine. So there's our ammonium salt. Okay. With OH. So what's going to happen? Put a base in here. The base is going to pull this hydrogen off here to form water. Okay, and it's going to leave our primary amine. Okay, so there's your alkyl ammonium salt, hydroxide ion to neutralize it, and your amine and water are formed. So by adding a strong acid to a water insoluble amine, a water soluble alkyl ammonium salt can be formed. That's what formed these right here by adding acid to it. Because you protonated it, you put a proton on it, you gave it a charge. Now it has polar, it's polar, so it can dissolve in a polar solution. The salt can just be converted back to an amine by addition of a strong base. Okay, so if we think about that for a second, if we have an amine and we add an acid, we're going to form the alkyl ammonium salt because we're going to add that proton to the freestanding electron pairs on the nitrogen. That's if we add a strong acid. If we add a base absorbs proton. So it's going to take that alkyl ammonium salt, that extra proton, and take it off of there to form water and a salt, and then regenerate your initial amine. So depending on what we want to form, we can add an acid or base and get the result that we want. Okay, so the ability to manipulate solubility, because remember, this is insoluble. This is soluble. So we can change to what we want. Okay, so to manipulate solubility of physiological active amines through interconversion, which is by adding an acid or base environment. And it's corresponding, it's important in the development, manufacture, administration of many important drugs. So we use that a lot in determining these drugs. Okay. Again, this is an amine compound. You can see it up there. We're going to add HCl to it. Again, this has, okay, whoa, let me go back a second. Get back to where I was. There we go. All right. See right here, this amine has free bonding electron pairs. So if we had acid, hydrochloric acid, that hydrogen is going to be pulled off here. It's going to attach here, giving this a positive charge and giving you chlorine minus. So you can have your chloride salt. That is now water soluble, can be delivered to the body and the delivery system. Okay. So we've added this salt to make this thing polar. Okay. So this is crack cocaine. This is a chemical formula for it. Doesn't do anything to the body, and now you've made it polar by it. Okay. This is cocaine hydrochloride, which is dissolvable in a polar compound and can be injected now. Okay. So pure cocaine is an amine and a base.
Just the chocolate.
Okay. This form of cocaine is referred to as crack or free base cocaine, found in relatively large crystals and may vary in color from white or dark brown or black. Like it's called black ice is this type of cocaine when it's for sale. Okay, so this is crack or free base cocaine because it's not soluble in water. When amine reacts with an acid, the alkyl amino salt is formed. This takes cocaine and makes it soluble. Okay, when cocaine reacts with hydrochloric acid, the product is cocaine hydrochloride. Now you can inject it. Okay. So the salt of cocaine is a powder, and the salt is soluble in water. Okay, since it's a powder, it can be snorted, and it'll absorb across the mucous membranes of the nose because it's soluble. Okay, it dissolves in fluids in the nasal membranes and absorbed into the bloodstream. Okay, this is a common form of cocaine because it's the direct product of the preparation from the cocoa leaves. Okay, it's a cocoa paste. It's made from the leaves, and they mix it with hydrochloric acid. Okay, and water. After processing, the product is the salt of cocaine. So there's the crack, and you call what's called free basing it. Okay, and you form the powder, which is you can sniff it or you can put it soluble in a compound and inject it. That's what the cocoa plant looks like. So crack cocaine is a non-water soluble base, okay, with a low melting point and a crystalline structure. Now you still can use crack cocaine. You can smoke it. Okay. Powder cocaine is water soluble salt of the cocaine base. Cocaine is extracted from the leaves of the cocoa plant. And cocaine hydrochloride salt, when mixed with a hydrochloric acid, can be converted into its base form by a process called free basing. Okay. Although the chemistry is simple, the process is dangerous, requires highly flammable solvents. And a lot of these blow up on people. The pure cocaine is not soluble in water. You have to have the salt form to be soluble in water. Okay, low melting point, and it can be smoked. Okay, so crack. Why do they call it crack? It's because it makes a crackling noise when it's smoked. When you crush it up and smoke it, it makes a crackling sound. It's absorbed in the body more quickly than sort of powder and results in a more immediate high for the crack cocaine. Okay, and that's where you get the name from. Okay, methamphetamines. Methamphetamine is an addictive drug known by many names: speed, crystal, crank, ice, glass. Okay. It's bitter tasting, odorless, crystalline powder, is easily dissolved in water or alcohol, polar compounds. Methamphetamine was developed in the early 20s. It's used as a decongestant in nasal and bronchial inhalers.
Where do you want to go?
Okay. Now it's really used for medical purposes. Most of the methamphetamine out there is for illegal purposes. In 2002, Human Health and Human Services Survey revealed that 12 million Americans aged 12 and older have used methamphetamine. Okay. Use of methamphetamine was associated with white male blue collar workers. Now has a much more diverse audience. Much more people use it. Okay, although it is used by people in jobs such as long distance trucking, help keep people up, requires long hours, mental and physical alertness. It is disturbing that the use of methamphetamine is becoming increasingly associated with sexual activity, teenagers with rave parties, homeless people, and runaway use. See a lot of methamphetamine use now. Okay. Methamphetamine can be smoked, taken orally, snorted, or injected, depending on the form of the drug. It alters the mood differently, depending upon how it is taken. Okay. So smoking or injecting intravenously results in what's called a flash, which is an intense rush that lasts only a few minutes when you smoke it or inject it. Okay. This may be followed by a high that lasts for several hours. Snorting and oral ingestion, okay, results in a euphoria that lasts 3 to 5 minutes. In the case of snorting, up to 20 minutes in the case of oral ingestion. So different effects, different its delivery route. Okay, because the pleasurable effects are so short-lived, methamphetamine users tend to binge to try to sustain the high. If your high lasts for 20 minutes, it means every 20 minutes, you're going to take another hit of it. Okay, so you binge use it. Both the intense rush and the longer lasting euphoria are thought to result from release of dopamine, okay, and norepinephrine in the region of the brain that control feelings of pleasure. So that's what starts to mimic the dopamine response in the brain. Once inside nerve cells, methamphetamine causes a release of dopamine and norepinephrine. Those are neurotransmitters. So they stimulate certain events from the brain, from your pleasure centers. Okay. At the same time, it inhibits enzymes that would normally destroy these two neurotransmitters. So normally we break them down, now it's not being broken down. Okay. And the excess transmitted neurons causing sensation and pleasure to last longer because it's stopping the breaking down of the product of the neurotransmitter. Okay. The excess norepinephrine may be responsible for the increased attention and decreased fatigue associated with methamphetamines. It's an upper. Okay. Symptoms of long-term use include addiction, anxiety, violent behavior, confusion, as well as psychotic symptoms of paranoia, hallucinations, and delusions. In severe cases, paranoia causes homicidal or suicidal feelings. Methamphetamines also increase heart rate and blood pressure. It's a stimulant. It can cause strokes, which is irreversible damage to blood vessels in the brain, as well as respiratory problems, irregular heartbeats, and extreme anorexia. Okay, if you're using the drugs like this and it's causing damage to your brain cells, you gotta remember there's certain cells in your body that will never regenerate. One of them is neurons. You're born with as many nerve cells as you're ever gonna have. Okay, nerve cells do not regenerate. If they are damaged from methamphetamines, from crack cocaine, they do not replace themselves, period. They'll never be replaced. Nerve cells and skeletal muscle cells. Skeletal muscle the same way. You damage your muscle cell, it will never be replaced. You can never grow new ones. You're born, you're going to get, you can make them bigger, but you can't replace them. And same with nerve cells. So when these nerves are damaged, there's no replacing them. And it's a cumulative effect over time. An extreme situation can cause cardiovascular collapse and death. So no physical symptoms come with withdrawal from the drug, but psychological symptoms like depression, anxiety, aggression, intense cravings are common. Okay, so methamphetamine is not physically dependent, but it does have some psychological problems upon withdrawal. Okay, greatest concern is brain damage that occurs over long-term use. Like I said, if it damages a neuron in the brain, damages a neuron anywhere in the body, that neuron will never be replaced. So as you use it, and it damages more of these neurons, because the uptake can't occur with the norepinephrine and the neurotransmitter, those neurons get damaged, they can never be replaced. Dopamine release may be the cause of the drug's long-term toxic effects. Okay. Research has shown, okay, that 3 years after chronic methamphetamine use, okay, the former user continues to have reduced ability to transfer dopamine back into nerve cells. So it's damaging nerve cells with chronic use. And they can't reuptake the norepinephrine and the dopamine as neurotransmitters. Compare the structure of the neurotransmitter dopamine with that of methamphetamine. They're very similar. Everything revolves on shape. So it stimulates the same receptors as dopamine stimulates. Okay. So if we look at this is dopamine. Okay, we look at this. That is methamphetamine. You can see the similar benzene rings. Dopamine, you can see it's a little more polar because they have two alcohol groups attached to it. But you can see that the amphetamine, you can see it's a very similar structure, very similar shape. Parkinson's disease, characterized by a decrease in dopamine producing neurons in the brain. So it's a logical look for similarities between methamphetamine users and those suffering from Parkinson's. Okay, so the brains of methamphetamine users shows damage similar, but not as severe as that in Parkinson's disease. So it's doing the same effect on the brain, the same damage that Parkinson's disease does. Okay, research at animals ever said that 50% of the dopamine producing cells in part of the brain may be destroyed by prolonged exposure. Okay, and that serotonin containing neurons may sustain even worse damage. Serotonin controls your sleep patterns. Okay, so it's affecting the memory parts of your brain, the dopamine producing one, the pleasure centers, and then the serotonin uptake receptors also. Okay, serotonin controls your moods. Methamphetamine uses continues to rise. It's easily synthesized or cooked. Okay, you use recipes. You can find those all over the internet, ways to make methamphetamine. It's real simple to make. It just takes 3 compounds. Okay. You start with ephedrine, you need acid, muriatic acid, like from a swimming pool, and ammonia. That's all you need to make crystal meth. Okay, but the problem is that the byproducts and the halfway point are extremely flammable. So the stuff you use is very flammable. So every once in a while you see these little smoke clouds out in the desert. That's where a meth lab blew up, because they're not usually the brightest people making this stuff. Okay, ephedrine is over-the-counter decongestant drug we talked about, is a starting material. Okay, it's simply reduced to produce methamphetamine. Very easy to do. Okay, how do you produce it? So you've gone from ephedrine to methamphetamine. Okay, just by reduction. And we do it. We make it with acid to pronate it, make it soluble, and then we reduce it. Okay, that's ephedrine, and that is methamphetamine. Okay, so with synthesis involving a variety of dangerous chemicals, includes anhydrous ammonia, okay, anhydrous hydrochloric acid, sodium hydroxide. Most meth kits do not have formal laboratory training. Most don't. Okay, but if you're going to make it, it's not that it's hard to do. It's just that it has to take very precise, and if you do it wrong, it will explode on you, and it will take the whole place up with you. Okay, so meth lab fires are common in synthetic products, and the synthesis produces toxic waste. The cleanup, followed by a major meth lab like, took 8 days and required 50 people just to clean up the meth lab. It contains a lot of dangerous materials that are byproducts of methamphetamine synthesis. Over 4 million pounds of toxic soy and 133 drums of hazardous waste were removed from the site, and it cost about $226,000. There's a lot of waste products, and it has to be cleaned up when you find these meth labs.